Hello students, so let's try to solve one more problem from IIT JAM 2022. It's a MCQ 2 marks problem, and this problem is again from mechanics and central force problem, mainly Kepler's law. So there is a some planet which is moving around sun. The mass of planet is small m, and mass of sun is given capital M, and it is also given g as gravitation constant. And it is given that the shortest distance from sun to this planet is small r, and this greatest distance is all about capital R. So here small r is just a variable given in problem. So we can assume that this is my r dash, that is my variable. Small r and capital R is basically parameter of this particular ellipse. So we have any arbitrary point, we can say that this is r dash and theta. So what we have to do, we have to calculate the angular momentum of this particular planet. So this problem is quite simple one. What you have to do, you can just write total energy, and total energy is given by half m, and I have taken that r dash dot square because I have taken r dash as my variable because r is given as parameter only. And then we have j square upon 2m r dash square, and we have potential energy. This is rotational energy, this is translation kinetic energy, and the potential energy is minus g capital M small m, and this will be r dash. So we have this particular thing, and from the Kepler's law we also know that energy of elliptical orbit is given by E is given by minus g mm by r maximum plus r minimum. So here the r maximum and r minimum is given by capital R is r maximum and small r is r minimum. So we can write minus g mm upon r plus small r. So this energy is constant. So we can write this value is minus g mm upon r plus small r is equal to half m r dot dash square. This is your variable because again I am saying that a small r is my parameter, and this is j square upon 2m r dash square minus g mm upon r dash. So now we know that this point, this r minimum and r maximum is also turning point. So if it is turning point, that means at this point r dot dash is equal to r dash dot is equal to 0. The translation the translation velocity is 0. So at any point you can take either at r minimum or r maximum. I am just taking at r maximum. So at r dash is equal to r, we have r dash dot is equal to 0. So we can put all this thing here. So this value is minus g capital M small m, and r plus r is equal to, this value is 0. At the r dash is equal to r, you can check it with r dash is equal to small r also, the answer will be same. And j is my angular momentum. So j square upon 2m r square minus g capital M small m r. So from this equation we can solve for j value. So when we are going to solve for j value, then we can take minus g mm as common. Then this value is, this will come into this side. So plus I am taking minus. So this value is minus. So this value is 1 upon r plus r minus 1 upon r. And this value is equal to j square upon 2m r square. So when we are going to calculate it, that value is minus g capital M small m, that is sorry, this will be capital R actually. This will be capital R. So R minus R by R plus R into capital R, and this value is J square upon 2m R square. So now when we are going to solve this particular equation, we can easily figure it out, the value of J. Let's try to calculate the value of J here. So this capital R is going to cancel out. This minus sign, and this minus sign is plus 1. So we have G M M upon R plus R into R, and small r is equal to J square upon 2m R square. So now we can take this, and this is your capital R actually. This is your capital R. So when we are going to solve this particular problem, particular equation, then we can have J square is equal to G capital M square R square R by, and this 2 will be also at the above, and we have R plus R into capital R. So one capital R is cancel out, and we can have value of J, and this J value is small m, we can take common, and that is root part 2G capital M R into R by R plus R is your answer. So this will be your answer, and and you can check this thing from small r also, the answer will be same, because the beautiful part is that when you will solve with the small r, then here a small r square will be there, and then here is r, and this part will be capital R. So again answer will be same. I will request you just try to verify this thing for small r also. So this is the value of angular momentum for this particular problem. It's a very nice problem, and you can apply all this concept of Kepler's first law, that conservation of energy, as well as the concept of what will happen at R maximum and R minimum. These 2 points are turning point. This is the crux of this particular problem. Thank you.